Okay. So quick recap, Pythagorean theorem, something that we've probably heard and dealt with before. A squared plus b squared equals c squared. It can only be used with right triangles, and c squared has to be the hypotenuse. A and b are just one of the legs. It doesn't matter which one's which. And, if we get good with doing some math in our head or just with using this formula over time, the hypotenuse, c, you just take the square root of both sides, right, to get c by itself. We don't have to worry about that plus or minus because the side length is always positive. And if you need a leg, again, it doesn't matter whether it's A or B. You have to subtract the other leg squared over and then take the square root. So that's why we get this c squared minus b squared thing going on. But again, that's just kind of if we get comfortable with stuff. If not, just use this every time and solve for what you need. And we ran through a couple examples, and then I'm going to reiterate these Pythagorean triples that make these triangles a little easier. And again, the ones I have boxed in red here are ones you probably want to have written down. So what this means is if we have a right triangle and two of the legs are 3 and 4, then the hypotenuse is going to be 5. You don't really have to waste your time doing the Pythagorean theorem unless you want to be sure. And then multiples of these work as well. So if I had 6, 8, and 10, right, and if I doubled all these, that works too. Yeah. And now here's where we were working earlier in the year with our roots and how to deal with square roots a little bit. So these are really important. Not, I feel like we're probably pretty good with the Pythagorean theorem, but now we have to be careful with our square roots and stuff. So we're finding the third side. So this is our third side. Maybe I'll call it A, right? Because the hypotenuse is 2 square roots of 34. And if we use our Pythagorean theorem, a squared plus b squared equals c squared, then we get a squared. We don't know a, I'm looking for it, plus 6 squared is our other leg, equals our hypotenuse is 2 square roots of 34 squared. Okay, well, let's just subtract that 6 squared over to start and see what happens. So we have 2 square roots of 34 squared minus 6 squared. And you could probably put this in your calculator, but I want us to get used to it. When it says that we need to be in simplest radical form, that means that your calculator better not spit out a decimal. So, you can put maybe this 2 squared to 34 squared in your calculator, but if it spits out a decimal, that's not what it wants. So we need to understand what this means. And there's kind of two ways that I think we can go about it. So just off to the side here, I'm going to do 2 squared roots of 34 squared by itself. One way I like to think about it is since this is multiplication here, we can kind of distribute that squared. 2 squared is 4 times the square root of 34 squared, kind of cancels out, right, times 34, right, and get it that way. And then we get 136. Or, if you'd like, you could just think of what squared actually means. So we have 2 squared to 34 squared, which really means squared means something times itself, right? And there's multiplication all through here. This is 2 times the square root of 34 times 2 times the square root of 34, right? This is all multiplication. And we can multiply in any order. So I'm going to do these numbers first. 2 times 2 is 4. Square root of 34 times the square root of 34 is 34, right? And we get the same thing, 136. So here we do 136 minus 6 squared is 36. So a squared equals 100. Then we take the square root of both sides to get a equals 10. And again, we don't need plus or minus because we're talking the side length of a triangle. So can't have a negative side length in this case, so we don't worry about the plus or minus. And so we just get A equals 10 for that. That's our missing side. And just to note, here's where we, maybe would have to be careful with our triples. Let's assume that it gave us 6 and 10, right? Then, right, we know 6, 8, 10 is one of our Pythagorean triples, and so you might see 6 and 10, you want to put 8 here, but that doesn't make sense because the hypotenuse has to be the longest side. So just watch out for that if we were going the other way. I will leave this up here for a second in case someone needs to get it down. Because we only have one more example, so we'll give it a little bit of time. And luckily, A equals 10 is in the simplest radical form. Nothing to really worry about there. All right, I'm going to move on to the next one. If you still have some stuff to write down, just leave some space because we'll have plenty of time at the end, and I could just go back to this example and let you write it down. All right. So find the length of the third side. So again, our hypotenuse is 7, so maybe our missing side length is A. You could make it B if you want. And we're using our Pythagorean theorem since we have a right triangle. And write it in simplest radical form. Okay. So again, we have A squared. We don't know A. We're looking for it. Plus 5 squared equals 7 squared. Well, we're going to have to subtract that 5 squared to solve for A. And we know 7 squared is 49, 7 times 7. 5 squared is 25. 49 minus 25 is 24. And so after subtracting the 5 squared, it's simply just simplified. You could also put that into your calculator, right? To solve for A, we got to take the square root of both sides. Then we get A equals the square root of 24. And delta math gives you square roots to use, but it says that we have to do this in simplest radical form, right? Up here, simplest radical form. Now we have to remember what that means. We should have gone over this in integrated math 1, and I think we reviewed it a little here, but here's kind of our review, right? There's kind of 2 ways to go about this. So if I'm just going to take this off to the side. If I have the square root of 24, and I want to see if that can simplify, I kind of have 2 things I can do. I can run through my head, and I can think, can I get a perfect square that multiplies to 24? And, if you're just running through some multiples in your head, 4, right? 4 times 6 is 24, right? And since we're multiplying here, we can take one of these out, right? So 4 times 6 is the same thing as 24, and I chose 4 because 4 is a perfect square, right? And so essentially you can split that up, the square root of 4 times the square root of 6. We know the square root of 4 is 2, and then what's left over times the square root of 6. And the square root of 6 doesn't break up into anything nice. And then there's another way to do it, which we've probably seen before. We could take 24 and we can start making a tree, right? So 2 times 12, right? 2 times 6, 3 times 2, and that's all that those break up. And what this is telling us is that 2 times 2 times 3 times 2 is 24. And the whole idea here is when you had a square root. I heard this analogy actually for the first time. I've actually never heard this analogy before this year, but someone else told it to me. This is jail, right? The square root is jail. And I heard that you need a partner to get out of jail. So this 2 has a partner 2, right? So they get out of jail. But what happens is one makes it out. So one makes it out of jail and the other one gets shot, right? That's a bleak way to put it, but that's how I heard it. So the other one's gone. And then what's left, right? This guy doesn't have a partner and this guy doesn't have a partner. Even though there's another 2 here, he needs a partner, right? He needs the same partner. So what's really left is the square root. These are the ones still in jail. 3 times 2. 3 times 2, which is 6. So whichever way helps you think about it. Um, and it's the same thought process, right? 2 times 2 is 4. So we had the square root of 4, and that's why that came out as a 2. And 3 times 2 is 6, and that was just what was left over here as well. So our final answer in simplest radical form is actually going to be 2 square root of 6.